Okay guys, I've got a copy of the original function on the right here, f of t. So to make a sketch of the derivative of f of t, my advice to you is to mark some important points. Okay, start with your critical point. So I'm going to find my minimum point here at x equals 2. I've got a maximum point here at x equals 7. I've got an inflection point here at x equals 5. I've got another inflection point approximately at x equals 9. Okay, and then I'm also going to mark my endpoints. So at x equals 0, my endpoints, and then I'll also mark at x equals 12, I have another endpoint. So let's label these points, points A, B, C, D, E, F. So when you make a sketch of its derivative, you're also going to plot those points. So I'll call each point A prime, B prime, C prime, D prime, E prime, and F prime. So I'm going to plot the derivative, right? With those points, okay? So recall that the derivative is the slope of the tangent line that touches each point, right? That touches the graph at each point. So let's start with point A here. Hopefully you can see that that tangent line is decreasing, so that means the derivative is going to be negative. So when I plot A prime, I'm going to have to plot it below the x-axis. So if this is the x-axis, I'm going to have to plot point A below it because the derivative is going to be negative. Okay, so if you now you go, okay, well, exactly how negative is it? You're going to have to approximate the steepness of that line. So I'll go ahead and just tell you right now that the steepness of that line, its slope is approximately -4. So notice here that point A is at x equals 0. Okay, so I go at x equals 0, its derivative is -4. So I'm going to plot A prime right there. Okay, now let's take a look at point B and draw the tangent line that touches f of t at point B. So here you can see that that tangent line is horizontal. Its slope is 0. So at x equals 2, I'm going to go down and plot, right, 0. That's B prime. Okay, let's go to point C. Draw a tangent line to f of t. So draw a tangent line to the function at the point C. So at C, where x is 5, okay, we can see that the tangent line is increasing. So we know the slope is going to be positive, which means when I plot C prime, I'm going to plot it above the x-axis because its derivative is a positive number. So again, you're going to have to estimate approximately how big this slope is, and I'll go ahead and tell you that that's actually around 15. Okay, so the slope of the tangent line at point C, so when x is 5, so let's mark where 5 is here, it's actually 15. Okay, also another thing to notice is your inflection point. So on the original function, we have an inflection point at point C and point E. When you graph its derivative, so the derivative, these inflection points on the derivative will be either a max or a min point, okay? So if you take a look at point C is an inflection point where the function is increasing the fastest. So when you plot the derivative is going to show point C as a maximum point on the derivative function. Point E is an inflection point, which is the point where the original function decreases the fastest. So where it decreases the fastest on the derivative function, point E prime, that's going to be a minimum point. So let me go ahead and jump to point E here, and we'll come back and plot D in a second here. But if I take a look at point E and draw the tangent line that touches the graph at point E, so that's at I'll just say roughly 9, okay? So at x equals 9, let me plot it on the derivative function. That slope is approximately a -7. So at x equals 9 on the derivative function, I would plot E prime, so E prime. Right, I plot it below the x-axis because the derivative is going to be negative. The tangent line is decreasing. And here, this is where we'll have a minimum point on the derivative, okay? So again, that inflection point at x equals 5, okay, that's going to be a maximum point, and I'm going to call that C prime, and we have E prime. So let me go back now. Let's focus on point D. So again, point D, you can see that the tangent line that touches the graph at that point is horizontal. So point D is at x equals 7. So let's go to the derivative now at x equals 7. This is where I would plot right? The point right on the x-axis where y is equal to 0, because the derivative there is 0. So that is d prime. Okay, so I've got point A, point B, point C, and point D, and its derivative plotted. Oh, and I've also plotted E. So the only thing left is f. So let's go to the original function. I'm going to use purple here so you can follow along. Okay, so at point F, if you take a look at the original graph actually looks like it's going to have another critical point here. So this actually looks like it's the bottom, the lowest point of the function here. So we can approximate its slope, but I don't really know what it looks like on the right-hand side. So I can't assume that the derivative, right? So I can't assume that the derivative is 0. So the only thing I have to go by is to just kind of take a look at the tangent line that I'm kind of doing in blue here of the slope. So it is negative, so I'm going to plot f prime below the x-axis, but I kind of have to approximate the steepness of that slope. So the steepness of that slope is approximately -3, okay? And the reason why I'm saying -3 is because the slope of A was approximately -4, and I can see that this line is a little bit less steep than the tangent line at point A. So I'm going to plot E, or sorry, I keep calling it E, but this is F. I'm going to plot point F at x equals 12. So at 12, I'm going to plot it at approximately -3. So that's F prime. Okay, so how do I connect these points? Let me start with point A. So if you take a look at point A, I know there's a lot of markings on this graph, so let me see if I can choose a different color here. I'll use red. So as I go from, actually, let me choose a color that I haven't used yet. So how about orange? I know that's kind of hard to see, but let's go with an orange color. Okay, so we can see that as I go from point A to point B on the original curve, the slope is decreasing, and as I approach B, it's decreasing at a decreasing rate. So as I graph the points between A prime and B prime, it's still negative, okay, because the original function is decreasing. So all the points between A prime and B prime are going to be below the x-axis, but it's getting less and less steep. So that means that it's getting less and less negative. So that means that from A to B, it's kind of going to look like that. And then let's take a look at from point B to point C. So here the function is increasing at an increasing rate. So that means its derivative is going to be positive. So all the points between B and C are going to be positive, and they're going to be increasing because the rate, or the slope, is increasing at an increasing rate. So I would connect it like this. So it'll look something like this, okay? And because I know that I have a maximum point at C prime, I know that is kind of increasing like that. Now let's go look at the point C and D on the original function. So from C to D, again, you can see that the function is still increasing, but it's increasing at a decreasing rate. So increasing at a decreasing rate means the slope is going to go from a high number like 15, and then it's going to get lower and lower as I get to D. All right, but I know that I'm still staying above the x-axis because the slope is still positive, right? So its derivative should be above the x-axis. Now let's go from point D to point E on the original function. So again, we can see here that the slope is decreasing at an increasing rate. So that means that when I graph the derivative, it should be below the x-axis, all right? And again, I said it's decreasing at an increasing rate. So it's negative. It starts at a small negative number, and then the negative number gets bigger and bigger and bigger because the derivative is getting more and more negative. And as I approach E, remember, that's a min point, so I kind of know that's kind of curving like that. And then from E to F, we can see that the function is still decreasing, but it's decreasing at a decreasing rate. So again, the derivative is still going to be negative, but it starts from being very negative, like -7, and then it gets less and less and less negative, okay? So then I have an orange here. That's f prime of t. That's the derivative function.